Alright, so today we're going to talk about simplifying fractions. How to simplify fractions, okay? First of all, take a look at this. This is a fact. If I have A times B over B times C. Anybody know how to simplify this fraction? A times B over B times C. Chuck?
Is it AB over BC?
AB over?
BC.
AB over BC? No. Yeah, you get rid of the B's.
Oh, yeah.
Yeah, you cross. But what allows you to do that? We're going to use the commutative property of multiplication and rewrite, instead of B times C, what am I going to write? C times B. Can I do this? Okay, can I separate the two fractions since we're multiplying? Anybody know how to separate them into a product of two fractions? Samuel? Yeah, you could divide, but then can I separate them before I do? Yeah. Exactly. Isn't this the same as A over C times B over B? Isn't that what this is really? What is B over B, by the way? 1, right? Same thing over what? So you just get A over C. But then I have this one. Why do you think I need to write down these? What are these called? Restrictions. You guys remember restrictions? Why do I need to say B can be 0 or C can be 0? Exactly. So that's a good question. So we understand C, right? Because you got A over C. If C is 0, the denominator is 0. Why do I need to even mention B can't be 0? B is not even, I don't even see B. Why do I need to say B can be 0 here? Wait. Who knows? Livy? Yeah, there's a B in the original of the expression. Original expression had B in them. Does that make sense? So even though you don't see B, because we cancel them out, right? Imagine though, if B was 0, can you do 0 divided by 0? That's how we cancel these out, right? So we have to make sure that the original expressions, we gotta look at the denominator of the original expression. Does that make sense? So write this down. We need to write down the restriction. We need the restriction of the original expressions, not after when you simplify. Does that make sense? Because some of you say, well, do we even need to mention B? Well, even though you don't see B after you simplify, B was there in the beginning, right? Our original expression had B on the denominator. Does that make sense? So write that down. Whenever you do these things like this, you have to write down the restrictions. When you're simplifying these expressions, you need to write down the restriction of the original expression, not after when you have it simplified. Okay. So write that down. I'll wait, okay? Oh, yes.
If it says assume no denominator equals 0, we don't have to put restriction.
Right. If I said assume no denominator, yeah. If they say that, you don't need to write down restriction if they said assume no denominator equals 0. But then on your homework tonight, guess what? Yeah, you have to write restriction. That's why we're going over this again. Okay. All right. So when you simplify these, this is what you do. Okay. So take a look at this example. Take a look at this very simple question. Simplify this. 2 plus 3 over 2 plus 4. I bet everyone knows how to do this. What is going to be the answer if I have 2 plus 3 over 2 plus 4? Yeah. 3/4?
Yeah.
How many people say 3/4? Raise your hand. Okay, that's why I gave you this one. The answer is 3/4, huh?
It doesn't matter because then you guys, if you still add it out and then you divide it by whatever to get the smallest size.
Okay, so hold on. How many people say? How many people say? Okay, listen. How many people say that the answer is 3/4? Raise your hand. 3 people.
1 and 3/4.
How many people say the answer is not 3/4 but something else? Oh.
I got it right?
It's 5 cents.
Oh, wait, I think
2 plus 3.
All right, I want you to discuss with your group. Go ahead. I'll wait. Go ahead. What do you guys think? So Isabella, what did your group come up with? Did your group say that 3/4 is the right answer? No. Oh, what did you guys say the answer is?
we came up with 5.
Yeah, you came up with 5 over 6. How many people came up with 5 over 6 as the answer? Okay. The answer is, first of all, you have to still follow the order of operation. You guys remember?
Yeah.
Remember the fraction bar? It acts as a?
Division.
Yeah, but it acts as a grouping symbol. Remember? Fraction bar is like a grouping symbol. So you got to do this first. You got to add them together. 2 plus 3.
It's
And then,
frozen.
oops. You have to add the numerators together and the denominators together. Yeah. How did you guys get 3/4? I bet. Hold on. I bet a lot of you get. Wait a minute.
1 over 3/4.
Yeah. Can we just do this?
No.
And then like.
Multiplication.
Yeah. And then some of you. Yeah. If you did, even if you did this, you should have got to 1 and 3/4, which is still wrong. It's not either 3/4 or 1 over. Can we cancel this out like right now? Why can we not cancel them out?
Because they don't have common
They're not a common factor. You can only factor out a common factor, right? Cancel out a common factor. These are written as a addition, not as a product. You can only cancel them out because when you cancel things out, look at the one above. Okay, see, 1 and 4, 3/4 is wrong. Look at the one above. How are we able to cancel these out? Well, it's a product, wasn't it?
Oh yeah.
It was B over B times A over C, right? When you cancel things out, you're really dividing top and bottom by B over B here. Do you see the difference? Here you have it as an addition. You can't just cancel these out, can you? Does that make sense? So remember, fraction bar acts as a what? Grouping symbol. I should write this down. 2 plus 3. It's really this, isn't it? Be careful. You can't cancel things out like this, right? Do you see the difference? Please keep this in mind. Okay, some people are trying to so either they do this or they do over 2 plus 4. They cancel things out like this. Still wrong, isn't it? You can't cancel these out. This is wrong. Right? Fraction bar act as a grouping symbol. Please keep that in mind. I'm gonna put it like this. And you could separate them if they're all multiplying together like this, right? A times B over C times B. Then it becomes A over C times B over B, right? And it becomes A over C times 1, right? Do you see the difference, guys, here? All right, so keep this in mind as we do some examples, okay? All right. Take a look at example 1. It says 2 over 4y. Okay, it says to simplify. So, could I rewrite this as a product of two fractions? Claire, what do you think?
No.
No?
I don't think so.
What about, could I rewrite this as 2 over 4 times something?
1 over y. 1 over y.
Yeah, it's not y, be careful. It's 1 over y. Yeah, a lot of people will, they just see the y and then they write y. Then the y will go to the numerator, not the denominator, right? So this is 2 over 4 times 1 over y. And of course, we know what 2 over 4 is, right? Royce, what's 2 over 4? 1 half. So this just simply becomes, who could tell me the answer? How about Mimi?
1 half. No. 1 over 2y.
Exactly, because you get 1 over 2y. And why do I need to write down y can't be 0 there, class? Hold on. Hold on. How about Lindsay? Why do I need to write down y can't be 0 there?
If it's 2 times 0, then the y will be 0 and times 5.
Exactly. If y is 0, right, the original expression becomes, the denominator of the original equation becomes 0. We don't want that, because then it will be undefined. Does that make sense? Is it always going to be something can be 0? Could it be something can be like 2, 3, 4? Yeah, because we, okay, hold on. Yeah, okay, good. So anybody need more time for this? Very simple example. Okay. All right, let's move on to example 2. Okay, here's example 2. 2t plus 6 over 5t plus 15. And you may say, wait a minute, we just talked about we can't just cancel things out as it is, right? Because you have an addition sign in the middle. Can I simplify this any further?
Yeah.
How? Because it doesn't look like I could really, raise your hand if you think you know. How about Dana?
Like, you can take 2 out of 2 to the 6 and 5 over 5.
Oh, so we're going to learn something that we learned from previous chapter, which is chapter 5. Factor. We could factor out these numerator and the denominator, right? Because what do you notice about 2t plus 6? It has a greatest common factor of 2. What about the denominator? It has greatest 5. So somebody tell me how to write that. How about the numerator? Eric, how do I write the numerator? We're using the skills that we learned from previous chapter. Yeah, we're learning how to factor things, aren't we? Okay. Next, hold on. How about Jenny, how do I write down the denominator? Can I factor out the GCF from the bottom? 5 times, yes. That's right. And isn't this nice? Why is this nice? You see how factoring helps us to simplify also? When you have like fractions like this, right? You see how previous chapter is really helpful, factoring. Because if you didn't know how to factor, you will not be able to simplify this. Now, anybody see what to do? What does this mean? This is same as 2 times 2 over 5 times what? How about Michael?
5, 2/5.
Times t plus 3 over? Yeah. Class, don't they cancel out? What's same thing over same thing? 1. Okay, so what's the answer? How about Camilla? What's the answer? 2/5. Okay, if you write 2/5, you're almost done, but guess what, Camilla? You have to write down the restriction, not right? Okay, everybody think about what the restriction of this will be. I'll wait. Go ahead, everybody think about it. I'll wait. Okay, who can help me? Camilla, what did you guys come up with? Yeah, t cannot equal to -3. How many people agree with her? You're right, because we're looking for, remember we did this before? We're looking for when will t plus be 0, or kind of, that's what we're looking for. We don't want it equal to 0, that's why we have this not equal to sign, and then you subtract 3 from both sides, you get t doesn't equal to -3, right? That's what we want, isn't that right? Because if t was equal to 0, if t was equal to -3, the denominator would be 0, right? And we don't want that. Even though you don't say any t on that simplified expression, how come we need to mention something about t? Because we just, from the beginning, you have to write down the restriction of the original expression. Just because they canceled out doesn't mean you don't have to worry about it, okay? All right, do you guys see do you see how to do these? Okay, yeah, question?
You have to write t plus 3 can not equal 0 also?
No. This is, I'm actually, how do I figure out that t can be -3? This is the work I'm showing.
Oh.
I'm subtracting both sides by -3 like this, right? Isn't that how I get that? Yeah? Okay, let's look at example 3. So here we go, 2t plus 2 over t squared minus 1. It looks like there's nothing you could really do much here. Can I cancel out the t's and t's here like this?
Yeah.
No, you cannot. I just told you. Because there's addition, sign. These are binomials. You can't just cancel out these t's. Yeah, it's 2t plus 2 over t squared minus 1. So I cannot do that, right, Carolyn? You can't just like, remember that very first example I showed you? You can't just cancel these out, can you? That's wrong because this is addition. These are binomials. Remember, this fraction bar acts as a grouping symbol. There's really a parenthesis on top and the bottom. You can't cancel these out, the t's. Oops. Do you know what I'm talking about? All right, so what can we do here in this example? Like I said, you can't cancel this t and t squared out on the bottom because these are binomials. And there's the fraction bar acts as a grouping symbol. Okay, how about Jason?
You have the GCF of 2 on the top.
You have the GCF of 2 on the numerator, you're right. What about the denominator? How about Chuck?
I only knew the t.
Oh, you need, okay. Chuck, take a look at it. We have t squared minus 1. Let me give you a hint. 1 could be written as 1 squared, can you not?
Yeah.
So I have something squared minus something else squared. Do you know how to factor that?
Yeah.
What does it become?
T minus 1 parentheses squared. Right?
Difference of squares? You got something squared minus...
2 squared minus 1 squared.
No.
I'm confused.
Okay, hold on. Okay. So if you have a squared minus b squared, Chuck, that's a difference of 2 squares, right? Remember how that factors to?
T plus 1
Times? Yeah, you remember? It becomes t plus 1 times t minus 1, doesn't it?
Yeah.
Would you not agree, guys? And why is this nice? Because you see that there's a t plus 1 on the numerator and there's another t plus 1 on the denominator. Now, could we rewrite it this way? 2 over t minus 1 times t plus 1 over t plus 1. Is that okay?
Yes.
Do you see why I did this? I switched the order of the denominator, how they're multiplying these factors, right? So that you get the same thing over same thing. And you could cancel them out. Okay, who can tell me what to write now? How about Spencer? Exactly. Because t plus 1 over t plus 1 is just 1, isn't it? So you get 2 times t minus 1 times 1. And of course, you have to write down the restrictions, right? How many restrictions would you get on this? How about Song? How many restrictions would you get in this problem? 1? You think 1? Look at the original expression, right? You have to look at the denominator, but you got to look at how it's factored. How many factors do you have on the denominator? Say what? 3? Not quite. I want you to discuss with your group. How many restrictions would you get? I'll wait for you. Go ahead, everybody think about this. Alright, so how many restrictions do you think you're gonna get? 2. Why do you think we're gonna get 2 restrictions?
Yeah, why?
T plus 1, T minus.
Yeah, because you have t plus 1 here and t minus 1. After you factor out your denominator, there are 2 possible ways for this denominator to be 0. So you can't just look at the original denominator. You gotta look at you still have to look at the original expression, but after you factor out the denominator, then you will know how many restrictions you will get. You're gonna get 2 restrictions, aren't you? So what are the 2 restrictions? When will t plus 1 be 0, class? When t is equal to -1. When will t minus 1 be 0?
1.
So there are 2 restrictions. Do you see that? There are 2 possible ways for this denominator to go to 0. And again, yes, you do look at the original expressions, but you have to factor the denominator to see how many restrictions you will get. So you're right. So that's what you need to write down. I'm sorry. Here you are. Does that make sense? Okay, so this is the answer right here. Jason, does that answer your question?
Yeah.
Okay. All right. So let's look at the next example then. Here we go. Example 4 says 3x squared plus 5x minus 2 over 6 plus x minus x squared. Again, can I just cancel out x squared here and x squared up here? No, because when you cancel things out, you're really dividing top and bottom by that number you're canceling out, right? Do you see what I mean? So can I divide the whole numerator by x squared? Is that a greatest common factor? No. Can I divide the whole denominator by x squared? No, you can't just cancel those out. Yeah, so what are we going to do? You have to factor the trinomial. Do you know how to factor trinomials? Yeah, isn't that what we learned in last chapter? What about the denominator? Does it look like it's in standard form? No. So guess what? You need to rewrite that in a standard form. So when I do, don't I get this? Negative x squared plus x plus 6. By the way, do we like the first term to be negative when we're factoring? So how are we going to fix that? Okay, hold on. How about Claire? We don't want that. So the numerator is fine. It's positive 3, right? The first coefficient. So this leading coefficient is not positive. What are we going to do?
Take out a -1.
Yeah, so in other words, factor out a -1. So we're going to rewrite the denominator as -1 times something. What would that be? -1 times? In parentheses, x squared.
Minus x minus 6.
Exactly right. Does that make sense, guys? Now we have the 2 leading coefficients, right? They are both positive, and we know how to factor. Go ahead, everybody try. I'll wait. Okay. All right. Dakota, were you able to factor the numerator? Well, it's got 3x squared. So how many ways are there to multiply 2 binomials to get 3x squared? The first term, it has to be 3x and x, right? So how would that work out? Do you still need more time? Oh, okay. Let me give you more time, guys. Figure this out. I'll wait. Go ahead. Here we go. Dakota, so for the numerator, you know that it's a trinomial, so it's got to be 3x times x, right? Like this. Well, how many ways are there to multiply -2?
4.
So which one would work so that when you multiply, like vertically, you get 3x squared and then -2, and then when you do the cross, like this, you get the 5 as the answer. So -1 and? Would this work, class?
Yes.
Yeah, does that make sense? So that checks, doesn't it?
Yeah.
Okay. What about the other one? So the bottom one, it's got to be x plus something times x plus something else, right? Well, you have -1 there too, right? Okay, so what do you need? -3 and 2. Wouldn't that work?
Yes.
Okay, that checks, doesn't it? There you are. So don't you get this? By the way, do I like negatives on the denominator?
No.
Is there a way to move that negative to the numerator, -1 to the numerator? You just multiply top and bottom by -1. By the way, do you see how we get x plus 2 and x plus 2? They're the same factors. Now, could we cancel them out? Yes?
Yes.
What's same thing over same thing? 1. So here's the answer. How many forgot? Negative. Well, you could just write negative 3x minus 1 over x minus 3, or I multiply the negative to the numerator. Okay. And how many restrictions do you get? You get 2, don't you? Okay, because you have x plus 2 and x minus 3. Yes?
When you have your negative 1 times x minus 3, can you usually multiply that to get 3 plus x? Would that also work?
Where?
On your denominator,
Yes.
you have negative 1 times x minus 3.
Yeah.
You just distribute that back out and you get 3 plus x.
Yeah, so if you wanted to, guys, so this is what Jason is saying, class. Instead of multiplying top and bottom by negative 1, can I just multiply negative 1 times x minus 3? Yeah, but normally we want the negative. You want the first term to be positive as much as you can, especially for the denominator. So that's why I multiply top and bottom by negative 1. And instead of multiplying negative 1, distributing negative 1 to the denominator, I distribute negative 1 to the numerator, as you can see right up here. So normally we like that better than, we like to keep once the denominator is in standard form, we want to keep the denominator, the first term of the denominator to be positive. Okay, so that's why we did this. But is it wrong? No, but this is the correct way. This is better. Any question? Do you see how I got rid of this negative 1 from the denominator, moved it up to the numerator? That's essentially what I'm doing, right? Just dividing top and bottom by negative 1 over negative 1, which is what? What's negative 1 over negative 1? 1. That's why I can multiply the fraction by negative 1 over negative 1. Right? I can multiply any number by 1. The end result is the same, right? Okay. May I move on?
Yes.
Here we go. Okay, take a look at example 5. It says solve 4kx plus x equals to 16k squared plus 8k plus 1 for x. Right, Christina? Christina? Right? Doesn't it say to solve for x here?
Yeah.
So how is this different than all the examples, Christina? All the other ones?
Because there's no denominator. Or there's like it's not a fraction.
Look at all your other examples. What do we do with all the other examples? Did we solve or did we simplify? Guess what we're doing now?
Oh, yeah, we're solving.
So what do we have? Instead of an expression, we have an equation. Now, I want to solve for x, which means what? What does it mean to solve for x? How about Tajwar? What do you think?
That you have to find out what x equals to.
In other words, get x by itself, right? So is there a way to get the x by itself? But I have a problem. I have 4kx plus x. I don't have x written just by itself right now. So, and then it's written in 2 places. What am I going to do? So that I can, is there a way to write 4kx plus x using just x once?
Yes.
Remember, we learned this. Okay, how about Angel? Is there a way to do that? How?
Oh.
Not quite. Look at x. You see the left side? X happens to be the greatest common factor of the left side of this equation, right? So could I rewrite this as x times something?
Yes.
How? X times? Exactly. Do you see why this is nice? 4k plus 1. That 1 is important, right? Can I just get rid of that 1? Does it equal to x times 4k? Of course not. If you don't believe me, multiply it out. What is x times 4k? 4kx. And what is x times what? Isn't this really 1x? Right? 1 times x. So that's 4. So x times 1 is x there, right? And now it equals to this trinomial. Guess what? How do I get x by itself now? How about Eunice? How do I get x by itself? Divide both sides by? Yeah, 4k plus 1. Isn't that what you do, guys? And of course, they cancel out. So you get x equals to this. We're done, right? We solved for x.
Yes.
Not quite. You should always, what does it say up there? Always?
Simplify.
Turns out that right side isn't simplified. Anybody see why 16k squared plus 8k plus 1 over 4k plus 1 is not simplified? How about many people? How about Matthew? Why do you think this is not simplified? You're right. You have a trinomial, you should see whether it factors. And do you think it's going to factor?
Yeah.
Yes, it will. Go ahead. Everybody factor the trinomial on the numerator. I think it's going to cancel out with the denominator. Okay, go ahead. Everybody try. I'll wait. Okay. Okay, so when you factor, how many people notice that, oh, it just becomes 4k plus 1 times 4k plus 1, and as you can see, as we hoped, right, you have a 4k plus 1 as a factor, just like the denominator, right? You see how you get the same ones? And you see how they cancel out? Give me just a sec. And then, of course, I get 4k plus 1, right? How come I only have one restriction for this one this time? Yeah, 4k plus 1, when would that be 0? You subtract 1 from both sides divided by 4. That's when k cannot be equal to negative 1/4. Does that make sense? Any questions? All right, good.